Hello, good afternoon all. Next speaker is with us, Mohammad Shobib Ahmad, sir. And sir's brief introduction is given by Professor Aruna Kamble ma'am. I will hand over to Professor Aruna Kamble ma'am.
Okay, good afternoon, participants. A warm welcome of all the participants for session 12 of day 4 Atal workshop on blockchain technology. We have with us Mr. Mohammad Shoaib Ahmed. He is a CEO and co-founder of Digital Notice Media Labs. He has worked on many projects in blockchain industry. He has worked as an advisor, as an educator, and a keynote speaker in many conferences around the world. Digital Notice Media Lab is a blockchain media and education company. So welcome to you, sir. So shall we proceed with the session?
Should I start?
Yes, sir.
Shall I start, ma'am?
Sir, we can start now. Hello. Hello. Hello, sir.
Okay. Hello, everyone. This is Mohammad Shoaib from Digital Notice Media Labs. And my company has been working in the blockchain education for quite some time. And we are partnered with a lot of colleges across India for blockchain education and other technical workshop and related programs. I myself has a experience of 4 to 5 years in the blockchain industry. I've been working as a investor first, then I started with a lot of blockchain stuff, and I started advising a lot of projects in the blockchain field. So I was working as the advisor with a lot of them. And today I'll be speaking on blockchain technology and decentralization, and also I will try to throw some light on industries to be disrupted by blockchain. So before starting, I just want to thank all the organizers of this workshop for giving us this opportunity to share our knowledge with each other. And as this is the fourth day of this workshop, if I'm not wrong, you must all have a very good understanding of what actually blockchain is, and what could be achieved from blockchain, and what exactly how exactly it works. And other speakers must have given you a good clarity of all these topics, but I'll be doing the same for sure. And but I will try to keep this session very simple and very basic, and will try to break each topic in its simplest form to make the learning curve quite easier for you. So I will be using a lot of examples and real world case studies to explain various topics. So, getting started with what exactly blockchain is, coming to the point, what exactly blockchain is. So, we've seen so many different definitions of a blockchain across internet. I've picked a few of them, and let's see what we can take out from these. What are the best terms that we can get out from these definitions, and we'll discuss those important terms separately in the future slides. And let's coming to the first definition that we have is a blockchain is essentially a digital ledger of transaction that is duplicated and distributed across the entire network of computer systems. So what we can take from here is the take is that it is a digital ledger and that too a distributed one. Coming to the second one, blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. So it's pretty much clear from this definition that it's trying to tell us that the system of recording this information is pretty much secure. It cannot be changed, it cannot be hacked, it cannot be cheated. So the simple thing is it's secure. Coming to the third definition, and that is, I guess, the most popular one, and that is blockchain is a growing list of records called blocks that are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and a transaction data. So it is just saying that it is a chain of blocks where each block is linked to the another block with the help of cryptography, and it uses a cryptographic hash of the previous block. Every block has the cryptographic hash of the previous block. So we'll discuss all these things separately in dedicated topics in the future slides. So coming to the two more definitions of blockchain, the fourth one says, in the simplest of terms, a timestamp series of immutable records of data that is managed by a cluster of computers not owned by any single entity. So here, what exactly the thing is that just give me a minute. I'm asked to. Okay, so I guess my camera is on now. It was off, so I was asked to switch on my camera. So sorry for the interruption. I'm not in the best of my shape. It's pretty cold over here at my place. I'm basically from Uttarakhand. So let's start. We were at the fourth definition, and the thing is, what exactly do we have at sorry, is here is that a blockchain is in the simplest of terms a timestamp series of immutable records of data that is managed by a cluster of computers not owned by any single entity. So here the focus is not owned by any single entity. That means it is owned by multiple entities. That means it's decentralized network. So we are here focusing on decentralized. Now coming to the last and the best definition of blockchain is that is a decentralized computation and information sharing platform. Here we calling blockchain information sharing platform that enables multiple authoritative domains. It now focuses on multiple authoritative domains that we discussed in the fourth one, who do not trust each other. Now this is an important point. Here these different nodes of this network do not trust each other, but they have to collaborate, they want to cooperate for this reason. Any business, it could be any sort of transaction among them where they want to cooperate, they want to coordinate, they want to collaborate, but they do not trust each other. And this is what internet couldn't do and blockchain did. Blockchain brought in the trust factor amongst all the parties, and it helped actually to let the nodes trust each other and try help them to cooperate. And this, so what are the key takes that we took from all this definition are that blockchain is a network, and that too a decentralized network. It is a digital ledger, that too a distributed one. It is secure, immutable, and it uses cryptography. The participants do not trust each other. These are the four main key points that we need to discuss further in this workshop and in this session. And let's come to the next slide. That is, what is a decentralized network? So talking about decentralization, so it's pretty much clear from the image you can see on the right of your screen that there is a picture of a centralized as well as decentralized network. So in the centralized network, there is one single decision-making authority, and but in the decentralized, there is no single decision-making authority. That means, for example, if we talk about a simple network of computers, and there is a server, single server, and there are others are nodes. The server give the decision, and the others have to just follow it. But in the case of a decentralized network, as you can see on the right one, all the nodes are equivalent. Anyone, all the decisions are taken mutually, and whether it depends on the network itself and the architecture of the network, whether there is a voting or what kind of consensus is taking place over there. But all the decisions are actually mutual. So now coming to the more depth into what decentralization is, that it is more secure as compared to the centralized network. So how it is more secure? Because as we told that every information on a centralized network is stored on a particular server, on a single server. If some hackers get into that, get access to that particular server, he can hack the information, and that could be it can do he can do anything with that information. But in the case of decentralized network, most of the times the data and the information is stored distributedly. Then it almost has a distribution amongst the different nodes. The information is being distributed amongst the different nodes, and if even the hacker tries to hack any particular node, the entire information is not gone, and the network can recover all the information back again if the hacker tries to tamper any information. But in the case of centralized network, if the hacker tampers the information, no other node can stop him by doing any sort of because there is no synchronization, because there is no distribution. So then, coming to the last point of decentralized network, I guess you must have a pretty good understanding of what decentralized network is, and it has no single point of failure. So if any node fails out any particular time in the decentralized network, the entire network does not fail and it still keep working the same way it was working. The only node that failed out is get out of the network, and the rest of the nodes still keep working. But in case of in the case of centralized network, if the main server fails, so this is called a single point of failure. The entire network fails. So the entire network will stop working if the server fails. So this is what decentralized network is. So for example, we'll talk about the Google Doc. Say for example, you have a Word file on your system that can be edited just by you at a time because you're using that system, and you want someone else to edit it. So what you have to do is you have to send that particular file to your friend, whoever, well, like say for example you want your friend to access that file to edit some information in that particular. So first of all you have to send that file to your friend. When your friend has access to that file, he can download it, he can then edit it. But in the case of Google Doc, this is a sort of a decentralized version of that particular document where the drive, the file is stored on your drive, Google Drive, and it could be shared with a number of people where you can share and the file with your friend, and you can give him the editing rights, and more than one people can do the editing part simultaneously. So in the previous case, what was happening, only a single person was able to edit a file at a particular time, and here in the Google Doc version, what we are seeing is that different people have editing rights, and they can edit or whatever and they could add any information or delete any information at a particular time simultaneously. So this is a sort of example of decentralization. But Google Doc is still have one owner. That means if you created that file, it is placed on your drive, and you are the owner of that file. You've given rights to the editing rights to other members, maybe your friends or anyone, and they can make editing to that particular file, but they cannot delete it, or they cannot prevent you from deletion of this file. So if you are trying to delete that particular file, no other friend can actually stop you. So this cannot be considered as the complete entirely decentralized example. Sorry, it could not be assumed as a complete example of decentralization, because here the editing rights are decentralized, but we are not using the distributed technology over here, because the file is still at a single place. It's not distributed with different people, because the file doesn't has a copy with different people. Even though people can copy a version of that particular file, but they cannot, that file is not simultaneously synchronized with it. So I guess you must have got a good understanding of what exactly centralization is, and what are the differences between a centralized network and a decentralized network. Now the question occurs, why do we actually need decentralization? Because ever since the internet has generated, ever since the internet has evolved, we have seen so many things happening on the internet, and everything was in a centralized manner, and we were pretty happy with everything. So why all of a sudden we need decentralization? So I'll give you some few examples where you will try where you will get a good idea of what is the importance of decentralization. So the very first one is the demonetization that took place back in 2016. So what exactly happened was that Mr. Prime Minister came out, and he said that and the 500 and 1,000 rupees bills will be banned, and they will not be considered as the illegal tender anymore. So this is one of the example of decentralization, where a single decision-making authority coming into in and forcing that particular decision to all the nodes. So, for example, we can think of the prime minister as the PMO, the PM Prime Minister office as the main server, and consider ourselves as the nodes. So whatever the decision was given from the PMO, we as the node had to follow that particular without any option. So it's the people who contributes to the economy, because we doing business, we are exchanging exchanging money, cash with anything, and that's how bit by bit economies of a country is built, and we were never asked before taking any such decision. So they took it. The PMO office themselves took that particular decision, and they never asked the people about it. They imposed that particular decision on the people itself. So this is one of the example of centralization is how harmful it could be, and how the decisions are being imposed on the people, on the other nodes, on the people, if we can say. So what should have been done in the case of decentralization, because it was the people's money and the people's opinions matters a lot. So if it would have been a kind of a decentralized network over here, the people opinion must have mattered a lot, because people opinions people would have given their different opinions about it, and different opinions must have they must have gone for a voting kind of a thing or whatever, and final decision could have come with a good consensus kind of a thing, and then only the final decision could have been made. So this was just a simple and very basic example of uh, the disadvantages of centralization. Coming to the next topic, the banks. We've been using banks ever since, and banks work on the centralized way. The banks also works in a centralized way because the leisure that banks hold is absolutely centralized. It is controlled by the banks. It's not controlled by anyone. No one can even see that particular leisure, whatever the banks are. And we've seen in the past that where the banks stop its account holder to withdraw their own money, because we've seen the PMC bank case in the past, where people were stopped from withdrawing their own money from their accounts. So the bank has no right to do any such thing, because it was absolutely people's hard-earned money. And how could a bank, how could anyone, in fact not a bank, how could anyone can force you into some sort of such kind of a thing that you cannot do something what exactly your right is. So we've seen other frauds as well in the past. Let's talk about the PNB and Nirav Modi fraud that was in the news a lot. And so in such a kind of cases, what exactly is happening when we talk about leisure? Banks always banks have their own leisure. These leisures are centralized ones. People have no access to such kind of leisures which these banks maintain. And who knows that whether bank tampers with these leisures at any given time, because say for example, who knows whether they deleted some transaction or created some fake ones for them in their favor. So nobody knows, because in that particular leisure is completely owned by the banks itself, not by the people. Even if we don't have access to those leisures, it's our money that we are keeping with, that is keeping the bank running, and we don't have access to at least if we can't have access to edit those leisures, which is not feasible, but at least we should be able to access those leisures. At least there should be some sort of logs that could be very much similar to blockchain, that could not be edited once written, kind of a thing. So that will make the banking system more transparent. So this is another example of centralization, what centralization can cause. The another example is data theft. As most of you must be aware of, our personal data is being stolen by the companies, the big tech giants like Facebook and Google, and this is being sold to the advertisers. So there are a lot of companies who wants to run their ads, and they want to target the people who are actually looking for their products. And Facebook and Google knows this, because they're tracking each and every single activity of ourselves. So if you're using an Android device, Google has been tracking everything about you, and Google knows you better than you, in fact, because every single activity that you doing on your Android device, or maybe it could be any other device. In fact, well, like iPhone is much secure as compared to the iOS, actually much more secure as compared to Android devices. But I'm talking about just Android devices. When you do anything on your Android device, any activity, and that's been tracked by Google. And what Google knows about you is that what kind of products you like, what kind of behavior have, what sort of videos you like, what sort of audios you like, what sort of songs you have interest in, and what are your interests, whatever. Each and every information is being stolen from your devices, and they are being sold to the advertisers so they can target the correct audience. So it's our own data. Google or Facebook doesn't have any right for selling it without prior permission. At least they should ask us before selling that particular data. So uh, and and on the other part, if we have any objection with any sort of such kind of a thing, we cannot do anything because they have everything in their hand, because all that particular data is on their centralized server. All that things, all the pictures we are uploading, all the searches are we making, is everything is stored on their own centralized databases. And these databases, and no one has access to them. So if we lodge a complaint, even if we lodge a complaint, and we cannot do anything, because they control all the data. They can suspend our account whenever they want without any permission from us. So this is what a good example of centralization is, to how harmful a centralization could be. So at least they should ask before selling someone's personal data. That's what I feel, because I'll be talking about some good examples of how helping people to save their, to protect their own data in the future slides. So that was all about a decentralized network, and that we've discussed what is decentralization is, what are decentralized network, and why do we actually need decentralization. Now let's talk about the second key take, the key point, that was it is a digital ledger, that is that to a distributed one. Now, in the early days, we know that we used to maintain an account register, known as Bahi Khata or Khata book, and where all the important financial transactions were stored. And most of us, in fact, do it till now, that in our daily lives, from basic. If we have any important transaction, we write it down in some sort of diary or some sort of account registration. We maintain it. I mean, every business has to maintain that whatever the financial inputs and outputs are, and all these things, and they have to maintain all these books throughout a financial year. And after that, they have to do a lot with the ITR part and kind of thing. Now, nowadays these transactions are stored on computers in the forms of various software. So, but still, and they are on a centralized, centralized system. Even financial institutes maintain their ledger on the servers. So let's talk about like the financial institutes like banks. Banks also maintain their ledgers. So everything that everywhere we can see the important transactions are being stored. So this is the example of a ledger, and these ledgers are typically centralized ledger. Like if we've talked about the case of bank, that these banks maintain their own ledger, and no one has access to that particular ledger. That is completely centralized ledger. And when we talk about a particular book, that particular book is um, about a account register. That account register doesn't have a copy of it. That is a single alone. If we lose that particular register, all our transactions are gone. If we store that such kind of transactions on a computer, and what if our hard drive crashes out, so all our data is lost. So that's how the things are. So we need a distributed ledger for such kind of things. I mean, in what is exactly a distributed ledger? That a distributed ledger is like each node in a network has a copy of their entire ledger. That means if say for example a node, if a network has a four nodes, as you can see in the picture itself on the right on the screen, you see that every single node has a copy of ledger, and every time any node enters information to any of this ledger on their own ledger, all the other nodes synchronize with that after the consensus is done. So this is what each node has a copy of ledger. These copies are synchronized when the information is added by any node. So this is what I'm trying to say, that when any node tries to enter information, all the other nodes synchronize that particular ledger and they synchronize their own. So a replica of each and every ledger is with every node. So new entries are only added after consensus among all the nodes is confirmed. So it's not like that any node can make any sort of add any sort of entry to it, whether it's valid or not, but it's added only after a particular consensus is done. And there are a lot of consensus algorithm we'll be talking about in the later part, and every entry is time stamped using a unique cryptographic signature. So to make it more secure, every entry that is made to such kind of ledger is time stamped using a cryptographic signature, or you can call it a cryptographic hash. So no one could actually tamper it. So all the distributed ledger are not blockchain. You have to keep in mind. So a lot of time blockchain is termed as a distributed ledger technology, but the fact is that blockchain is just one type of distributed ledger technology. It's not that the blockchain is distributed ledger technology. Is just one type of distributed ledger technology. Distributed ledger technology is much more than blockchain, and there are a lot of other things. There are a lot of other factors that are involved in the DLT rather than in blockchain. So, but here is a basic example of what exactly distributed ledger is and how blockchain is actually using it. So why do we need distributed ledgers? So again, the question is, so even the banks are hacked. We've seen in the past that a bank from the Bangladesh was hacked, and as we know that Bangladesh, as we know that banks have a centralized ledger. They were hacked, and all the information was forced in that particular ledger. It was tempered. Again, Swift bank hackers have attacked another bank in the Philippines using the same modus operandi as that in the case of Bangladesh Bank East. So we've seen such kind of cases in the past as well, and this could happen in the future as well. Though our banks are quite, and they use a lot of security, they use a lot of firewalls, but still what exactly is happening is the hackers can hack you anytime, and they may always be a loophole in some sort of system, and the hacker can take advantage of that. And when all the information is in a centralized form in a particular server, all the accounts could be hacked, all the systems, all the data could be tampered in that particular ledger. So that is why a distributed ledger is required. The bank's ledger should have multiple replicas of it. Maybe it could be among its own organization itself. I'm not talking about the backups, but it should be because backups are a different thing. Backups are a different thing, and a distributed ledger are a different thing. In distributed ledger, all the nodes have a replica of that particular ledger, but in the backup we keep up another copy of that particular ledger. So those are two different things. So hacking central servers, we've seen in the past that the land record software was hacked almost 3 to 4 times, and that too for the Karnataka's land records. And this is like very worrying kind of a thing, because say for example if someone enters the land record software, and he hacks it down, and he can change, he can tamper the ownership of any particular land, and he can take advantage. So this may mislead to a lot of things, and hackers can change the land cost, changing land ownership, and with the help of few clicks, a lot can be done, and such records should be stored in distributed ledger. So these kind of ledgers should be like distributed ledgers, and the government has already started putting up their land records on blockchain to prevent all such kind of things, because even though we've put all the land records digitally, but still they are running on a single server, and if a hacker enters that particular server, and if we get access to all the records, he can change anything, he can tamper any record in that particular server. So this is another reason why we take it. So now coming to the next key point, that is it is secure and immutable, and it uses cryptography. So now blockchain is a type of DLT in which transactions are recorded with an immutable cryptographic signature called a hash. So here what exactly you can see in the image, that the blockchain block, each block is in two parts. So the first part is the blockchain header, and the second part is the the transaction data. So in the top part, in the blockchain header, you see that there is a hash of the previous header. There is a hash of the previous block, and there is a Merkle root. Merkle tool is the hash of this particular block, and the blockchain in the transaction part, in the bottom part, you can see that is the data part, that is the transaction data. Now, what exactly is happening, that each block in the blockchain has the hash of the previous block. So that is why they are linked with each other. Each block has the hash of the previous block. This means when a block is completed, it creates a unique secure code. So and which ties into the next block. So this makes it very immutable. If, say for example, if a person wants to if a hacker wants to get into any such block and want to change any transaction, he will have to change the entire chain, which is like near to impossible, because there are a lot of millions and millions of blocks already, and that are in that particular chain. So it's very like difficult for a hacker to hack into it and to change such kind of transaction. Now getting into some more details of what exactly. So in the right side you can see the example of, and you can see the figure of how exactly a block looks like. So and the block in the top figure, you can see that is a block header that contains the block reference number, that is the nouns, and there is a previous hash of the previous block, and then there is the hash of this particular block. Now this hash, how this hash is actually created, when some transactions are verified, they form a block. So in the right side you can see in the figure over here, if you could see my mouse, this is transaction 1, this is transaction 2, transaction 3, and transaction 4. So every transaction here we use some cryptographic algorithm to create. We use some encryption, and after that the encryption, a hash is created. Now hash 0, hash 1, this is, and these are the hash of this particular transaction. These hashes are now like combined together in the form, a Merkle tree is formed. This is known as a Merkle tree. Now these hashes are make another hash, and that is how a root hash is formed. So this is how a Merkle tree looks like, and with the help of the Merkle tree process, we create the hash of a particular block. So if a hacker tries to breach into any block and tries to if he finds a way to change or tamper any transaction. Say for example, he wants to change the transaction 0 or transaction 1, the entire hash going from bottom to top will have to change, and it will change, and the hash will absolutely change over here. The root hash will change. So even if a single bit is changed in any of the transaction down the line, bottom the line, all the data, however, if TE1 is changed, then hash 1 will change, and if hash 1 is changed, then hash 01 will change, and if hash 01 is changed over here, then the root hash will change, and if the root hash is changed, so the next block will contain this hash. So this is what the root hash is, and the next block contains this. So this is why it is very difficult to hack such kind of to hack and tamper such kind of information which is stored in terms of in the blockchain. So each block consists of a block header and a transaction data. We've already discussed this. Transaction data is set of a few transactions that we've already discussed, and root hash or hash of a block is created using a Merkle tree. We've also already discussed it. And if even a single transaction is changed, the whole tree is affected and the root hash is changed. So we've already discussed this, that how difficult it is to tamper such kind of information that is stored in the block inside the blocks. So that is why it's immutable. Now what exactly is happening? Coming further, blockchain uses distributed ledger, means each node has a replica of ledger. Then so these are the different nodes. We have 6 nodes over here, and each node have a copy of that particular ledger. Now in case of Bitcoin blockchain, we're talking about just Bitcoin blockchain right now. A new block is generated or added to the chain every 10 minutes. So a new block is generated to the chain every 10 minutes. All the nodes synchronize their ledger after that particular. So when, say for example, this node generates a new block and wants to add a particular block to this its own ledger, this ledger is then synchronized with all the ledgers of other nodes, and the changes take place, and this is all done after a proven consensus. So what exactly is happening over here is that there is a time span of 10 minutes. So if a hacker wants to change any transaction in any particular block, he has to hack at least 51% of the nodes. So at least 4 nodes out of the 6 nodes. In this case, he has to hack them, and he has to make changes to all these ledgers at a single time. So and he has to do it within a span of 10 minutes, because maybe, like for example, if say for example this node over here, the bottom node is being hacked, and for example, or we can take example like the 4 out of these 4 node out of all these 6 nodes are being hacked. And what exactly is happening? The hacker is trying to tamper some information, but it's already been 9 minutes for him, and he's still he's done with 3 and he's doing the 4th ledger. But what happened is that the node that was left generated a new block, and because every block is generated in a span of 10 minutes. So what exactly is happening? A new block is added to this particular ledger, and then this particular ledger goes for a consensus, and all these ledgers are updated and synchronized with this one. So this is how the things are being done, because so if a hacker wants to change any particular block, he has to at least hack 51% of the nodes at a time, and for that he has only 10 minutes. So after 10 minutes the ledger will get synchronized itself. So it is near to impossible, because he needs a lot of physical resources for that, because in case of Bitcoin we have a different kind of a concept there, where a lot of electricity also used for verifying each transaction. So there will be a lot of cost involved in in like hacking such kind of a like system. So here we were just talking about six nodes, where we just have to hack four nodes. So four nodes so feasible, but when we are talking about a big Bitcoin network, what exactly is happening? There are millions and millions of nodes. So it's near we need a lot of physical resources to hack millions of nodes at a particular time, and we have to make those changes simultaneously, and we have to verify those transactions where electricity cost is involved. So a lot of resources are required, physical resources. So that is why it is very this system is very secure. Now the fourth part that comes is the participants do not trust each other. So one thing that internet couldn't do is the trust factor. It could not create trust between the parties. So even you, if you look at yourself and if you ask yourself that whether you can trust someone on the internet, I guess you will say no, because there are a lot of people asking to invest in so and so. So, but you want to meet them in person because you want to rely on someone on directly on the internet, because when it comes when anything comes in terms of money, you don't want to rely someone online who's been talking to you online, and you are investing because he's asking you to invest and you just invest. It's not like that. So that is one of the thing that internet could never do, that the trust factor. But blockchain did it perfectly and made the transaction completely peer to peer without the need of a middleman. And when the internet actually emerged and when evolved, one thing was expected from internet, that it will remove the middleman. So this was expected from internet, but actually what internet did is it created more bigger middlemen. Like for example, for example, we can say Amazon. Earlier we were buying from the offline stores, then we started buying from online store. But on the online store, when we are talking about purchasing online, we are not buying from any random website, because there is a trust issue. You have to find a third party. Still you have to find a third party to trust, to act as a middleman, and who wants to you want that party to take responsibility. So Amazon is acting as a third middle person, acting as a third party who you actually trust, and both the sellers and buyers are actually trusting this particular party uh, who doesn't have any product and who doesn't want to buy anything, but a buyer wants to use Amazon because he trusts Amazon. A seller wants to sell on Amazon because he trusts Amazon. So here, the if we talk about the offline market, we've removed internet has removed a lot of middle person, but they've created a bigger one in the form of Amazon, Facebook, and all that you can see. Now, what actually blockchain has done is blockchain has brought in the concept of trust back into the network, and people can easily trade peer to peer. The parties may do not trust each other. The parties may not trust each other. Maybe say for example there is a network of four people. It's very much possible that a person do not trust another party, but what he's trusting is the network, not the party. So this is called a decentralized trust. For example, I'll take an example of a kitty party, for example, and what happens in a kitty party? A group of four or five women, they sit together, they celebrate, and they contribute. And after the contribution takes place, say for example, there are 10 women, they're sitting down the table and they're enjoying, and they are contributing 1,000 rupees every month. And every month, what exactly, whenever they're contributing, what actually they go for is they go for a lucky draw, and one out of those 10 takes all the 10,000 rupees and can use it. In the next month, again, they're contributing again 1,000 each, and someone else will take the next month. So this is how the system is in the kitty party. If I'm not wrong, I'm just taking a very basic example. But exactly what's happening is maybe there is one woman who don't want to trust any other women when it comes in the terms of money. But who she's actually trusting is she's trusting the entire network over there, because she knows, see, that if a person sitting next to her, if she wants to defraud her, she at least have to influence 51%, that is 6 out of those 10 women, to take her side and prove you wrong. So that's how the network is. So this is decentralized trust, that you're trusting the network, and you know very well know that anyhow, if she can influence at a time, if she can influence at most 2, and the other remaining 7, include 8 including you, are on your side. So you cannot be defrauded by her. So this is how the decentralized trust works. So if a party wants to defraud any another party, he has to influence at least 51% of the parties to take his side. So this is what happening in this particular example of the kitty party, that you were not trusting the party, but you were trusting the whole network. So I guess I gave a very basic and simple example of what decentralized trust is, and how blockchain is bringing the factor of decentralized trust between two parties, and helping them collaborate. So this was our last definition, that was saying that the parties do not trust each other, but they want to collaborate, or they want to cooperate for whatever the reason it could be. So this is how the decentralization is trust is decentralized trust is working among these women or these parties. Now talking about the cryptocurrency, so I guess you must have got a good understanding of blockchain by now. I try to keep it very simple, very simple, and I try to break it down to the simplest form, whatever it was possible, and now after we've learned a lot of concepts about like these and like distributed ledger with decentralization and centralized network, a lot of terms we have already cleared. Now it's time for us to move towards the cryptocurrencies, because whenever we talk about blockchain, most of the people actually, the worst case scenario is that most of the people actually consider blockchain as the technology behind Bitcoin, but it's not entirely true, because Bitcoin is just an application of blockchain, but not the entire technology behind. Because we have different sort of blockchain present in the market, so it's not true that the blockchain is the defining blockchain as the technology behind Bitcoin. But let's talk about cryptocurrency. What exactly is a cryptocurrency? So most of you must be knowing what exactly cryptocurrency is. So I don't want to get into much deeper into it. So it is a digital or virtual currency that is secured by cryptography. So that is why it's named a cryptocurrency, because it uses cryptography, and it's a digital currency. People also call it a new form of digital asset. So there are a lot of different theories in the market, and some of them call it digital gold, and some of them called digital assets, and there are a lot of things. Defining blockchain as the technology behind cryptocurrency is not completely true. That's what I was actually talking about, like in my past sentence. So there are very few currencies that do not use blockchain, and sorry, there are few cryptocurrencies that do not use blockchain. So my past, if we talk about the third point, that defining blockchain as the technology behind cryptocurrency is not completely true. So this is proved with the fourth point, that there are few currencies that do not actually use blockchain. So there is a cryptocurrency called IOTA that is basically that was invented for IoT devices and that uses the Tangle technology. So Tangle technology is the technology of the IoT devices, where the concept of the project was that in future when the IoT devices will be able to communicate with each other and they would be able to transact a currency among themselves, and that sort of they have that sort of idea and they are still in the market. They're working great, and there are a lot of, I guess there are more than 20 million devices already on using IoT. So what exactly is happening over there is that all these devices can use that particular token as the core currency. But the fact is that these they are not using blockchain. But why do we actually need cryptocurrency? That the question is, why do we actually need cryptocurrency? So most of you must have a good idea of why do we actually need it. Some of us says that we want to the cryptocurrencies want to replace the fiat. So it is one of the reason and that Bitcoin aimed with. So now talking about it, that the purpose of cryptocurrencies also we're talking about in the case of Bitcoin, just in the case of Bitcoin to be, so Bitcoin aim to be a globally accepted digital currency or a digital asset, and it wants to be a single cryptocurrency, single currency of the world where it could be accepted everywhere around the globe, and it can have a same valuation everywhere. Say for example, right now, even if we talk in terms of fiat, uh, INR has a different valuation and a US dollar has a different valuation. We know that one USD is equal to 74 INR right now, but a Bitcoin is $20,000 today in India, and it's again $20,000 in US. So it a global currency that has the same valuation everywhere, that is accepted everywhere, that could be used everywhere, and in future maybe it could be considered as the legal tender by almost all the countries. Right now India doesn't consider it as a legal country. There are a lot more other countries which do not consider Bitcoin, still not consider Bitcoin as a legal tender, and even other cryptocurrencies as well. So to make the transaction peer-to-peer without the need of centralized validating middleman party. So another aim, Bitcoin has two purposes. The first one was to be accepted as the digital currency of the world, and the second purpose was to make the transaction peer-to-peer. If I want to send money to my friend, say for example, so I can send it directly using my Bitcoin wallet without the intervention of any, without the involvement of any third party. For example, let's talk about in the fiat currency. What happens when you draw a check, when you give a check to someone, the check is presented to the bank, and an employee sitting in the bank validates that particular check, and he checks whether that particular data with that transaction is valid or not, whether that particular amount is present in your account or not. When he sees, when he check out that that particular amount is available in your account, he clears the check and the amount is being then transferred to your friend. So this is how the thing works in the fiat system, in the SWIFT system. So what exactly is happening? You are trusting a middleman in there, and bank is the middleman over here. But in case of Bitcoin, if I want to send some money to my friend, I can directly send from my wallet to his wallet without the involvement of any third party, and all the validation part can be done by a middleman. Sorry, by the network itself. So this is how the things work in Bitcoin. So Now, these are the two purposes, but the main purpose of the cryptocurrency, of any cryptocurrency, is to provide incentive to the validators to keep the network running. Now, what happened in I given you an example of the banks, like when you present a check to your friend, he gave it to the bank for the clearing purpose. So bank is actually doing all the validation part. He's checking whether the amount is in your account is sufficient or not. So he's doing that because he's getting a salary from the bank. So if you don't give any salary to the bank, or if the bank doesn't charge you any fee for any such kind of services, how would the bank run? And why would that person without getting a salary would work and clear your check? He was doing it because he was getting a salary for it. He was made to do so. He was sitting over there for that particular purpose. That's why he was clearing that particular check. Now, in the case of Bitcoin, when the network itself solves all these problems, why would someone in the network would validate that particular transaction which you are trying to send from your wallet to your friend's wallet? So someone is actually validating it amongst the network. It's any node from the network is actually validating it. So why would that node validate it without getting any incentives? So this is the logic behind a blockchain, is that the network actually is the network is actually validating all the transactions itself, and in return it's getting some rewards for that particular thing. So after every block generation, the validators are giving some rewards in cryptocurrencies. So there are around 4,000 cryptocurrencies in the market right now, example Bitcoin, Ethereum, etc. So this is how the working of like this was the purpose of cryptocurrency. Now talking about the cryptocurrency wallets. So I guess if we can take some questions at the end, if someone has questions regarding the purpose of cryptocurrencies, or any topic we've covered in the previous slides. Now we talk about the cryptocurrency wallets. So what is a cryptocurrency wallet? So it's like your bank account, kind of your bank account, but not exactly your bank account. A cryptocurrency wallet is the app or hardware that allows cryptocurrency users to store and retrieve their digital assets. So what exactly is happening here? You can have, there are a lot of cryptocurrency wallets present in the market, and you can install them on your device, or you can have a hardware wallet. There are two types of wallets. I may clear that one is called one of them is called cold wallet, and the other one is called hot wallet. So hot wallet is like a cold wallet and hot wallet, or you can call it a like a hardware wallet, or a soft wallet is like your desktop wallet, mobile wallet, and all that. Those come in under the software wallet. And hardware wallet are like your they are like pen drives, and they pre-installed with some sort of softwares, and that holds your cryptocurrency. So now user can transfer crypto from one wallet to another using a wallet address. Now every cryptocurrency wallet has a wallet address, and that address is unique. And there are many wallets in the market which can hold more than one cryptocurrencies. So they can support a lot of cryptocurrencies. So each cryptocurrency in any wallet has a different address for it. So let's talk about more about the wallet address. So each cryptocurrency has a different patterns. So in the right hand side, on the right hand side, you can see a wallet address of Bitcoin. You can see the pattern. You can see the cryptography version of it. The address. This is somehow the address is, and you can use this QR code as well to pass it to someone who can scan it and send funds to send bitcoins to your address. And this is how the address of this is a pattern of Ethereum in the red one here down there, and this is how the Ethereum address looks like. So each cryptocurrency has a different address pattern. So if you send say for example send some Ethereums to a Bitcoin address, so those particular coins will get lost and you cannot recover them. Same is the case with any cryptocurrency. If you're trying to send some uh, BTC, that has to be passed, that has to be they should be transferred to a BTC address only. So BTC can be transferred to a Bitcoin address only, and Ethereum can be transferred to a Ethereum address only. So this is, I made it very much clear that every cryptocurrency has a different pattern because they uses different blockchains and a different mechanism behind them. Maybe they're using different cryptographic expression algorithms, like Bitcoin uses SHA-256, and maybe Cardano. I'll be talking about Cardano. This is also a cryptocurrency that uses a different sort of algorithm for this purpose. So they cannot be encrypt and decrypt by different things. They cannot be cross-chained, and there are certain projects going on where we can swap uh, BTC to Ethereum or Ethereum to Bitcoin, and that could be done. And that is cross-chain transfer is also will be available in the coming future, because a lot of work is going on that particular thing. But for now, you can send BTC to a Bitcoin address only. You can send Ethers to the Ethereum address only. Otherwise, your funds will get lost. Okay, now we were talking about the cryptocurrency wallets and wallet addresses. Now, every cryptocurrency wallet has two pairs, has a pair of key. I mean, has two keys. That is, one is a public key and the other one is a private key. So the public key is the one from which your wallet address is generated. So that particular in the top right, in the top right, you can see that is particularly a Bitcoin address which you have to share with all the participant, all your friends who wants to send you some Bitcoins. So this is the address you have to share with them. And another key is the private key. So in basic cryptography, in basic encryption, decryption, you must be aware that when we encrypt a message, a digest is formed, and to decrypt that particular message, a private key is required. So with the help of public key, we encrypt something, and with the help of a private key, we decrypt something. So the same logic is being used over here, and the public key generates your address for the wallet, and the public key and generates the address of your wallet, and the private key is the secret key that you have to keep it secure, because if you lose that particular key, you will not be able to access your own funds. Or if someone else has access to your private key, he will have access to your funds. So you have to keep your private key very secure. This is in the case of any cryptocurrency. This is in the case of any wallet. So each wallet has a pair of keys, public key and a private key. Your wallet address is generated from the public key. We've already discussed this, and you can share it, and people can send funds to your wallet. So you get access to your wallet funds with your private key needed when sending funds. So if you're trying to send some, if you have to send some, if you have to send some funds to your friends, say for example, so you need that particular private key before sending funds, because you need to access your own funds before. So when you will access your funds, then after that only you will be able to make a transaction of it. So again, the note is that never share your private key with anyone. It will give access to your funds. So there is a common saying, there is a very famous saying in the cryptocurrency, cryptocurrency field that if you don't own the private key, you don't own your funds. Got it? If you don't own your private key, you don't own your funds. It's a very famous saying in the crypto. Now, again, we were talking about crypto wallet, of course. So it is now, it is not the wallet that holds the fund, but the blockchain ledger. Now, most of us think that I have a wallet installed in my phone, like mobile device, and my bitcoins are in my phone. They consider it like that. And what if my phone get lost? So I lose all my funds. I lose all my savings because my funds were in my phone. So it's not the wallet actually that holds the fund, but the blockchain ledger that stores the information, how much funds are available at the particular address. So this is very much same like the bank account does not hold the physical money, but the bank ledger stores the value. So for example, let's take the example of the bank itself. So when you want to transfer, say for example, uh, 1,000 rupees to your friend, it's not the physical money that flies from place one to place A to place B, or from a person A to person B. It's not the physical money that flies, but the transaction that's been taken is the ledger that stores the value. Now, what actually happening when you are trying to transfer that 1,000 rupees? What exactly is happening? Someone sitting in the bank will validate the transaction and will debit that 1,000 rupees from your account and will credit in your friend's account. So what's the account we are talking about is he is updating the bank's ledger regarding this. So your account does not contain any physical money. It is just the figure that is being showed, that is being issued by the bank's ledger. That's what that is what the value of that particular amount is. Similarly, in the case of cryptocurrency, the wallet doesn't hold the coins. So if you lose your phones at some point of time, it's not that you've lost all your coins, it's because it was just a medium for accessing your funds and to send it to someone. So it was kind of a easy. So you can like you can have access to that particular wallet in any other device using your private key. Again, using your private key, that is why the private key you have to keep it very secure. But yes, if your private key is lost, no one could be able to withdraw those funds, because no one can actually have access to that particular address, because no one can actually hack into it, because it's like it uses a deep cryptographic algorithm for that purpose. A lot of encryption is being done over there. So I guess you must have got this. If a transaction takes place, the amount debited or credited is updated in the ledger. This is what I was trying to explain, that whenever the transaction happens, the amount is credited or debited, and your wallet shows the updated amount in the real time. So whether it's your bank account or your crypto wallet, same thing is happening. In the case of bank account, your bank's ledger was being updated, and when you use mobile app, mobile banking or whatever, and you try to check your balance, the updated value from the bank's ledger is being shown to you. And same is in the case of in the cryptocurrency wallet, when you actually send some amount to your friend, the blockchain ledger that was actually holding, that was storing that particular value, from where the validators were validating that whether your address has that amount of money or not, will be checking it and will be updating it. And after that, the real time, in the real time, whatever the updated value will be, your wallet will be showing that particular amount. So what exactly is a hash or address scan? So after any transaction that take place, a transaction hash is created and anyone can scan it. So because it is a decentralized network. It is a decentralized network. It is a distributed ledger, and it's not the case in bank, because in banks we can only access our own account. We cannot access anyone else account or anyone else transactions. But here what exactly is happening, you get a transaction hack for every transaction you make, and you can use various services like bitcoin blockchain.com explorer and for bitcoin scanning, and you can use ethereum for scanning Ethereum transaction. You can use Etherscan. So you can simply see look into the application. You can put in the any public address of a wallet. It will show you that what are the amount, what is the amount stored in that, how many bitcoins are stored in that particular address. Or you can put in the transaction, as it can show you that whether the transaction has taken place or is still under process, or how much transfer, how much amount of bitcoin was transferred but in that particular transaction. So everything is actually included in that in transaction. Same is the case in Ethereum. In the Etherscan, you can find out that every transaction you make, every you can put in your transaction has, and you can find out that whether the transaction has taken place or not, and what was the amount, and what address it was sent from, and what address it went to. And you can even scan those particular addresses, and you can find out the how much amount of Ethereums are present in that particular address, or any ERC token present in that particular address. So I guess we've discussed a lot of terms, starting from the security, the decentralization, and the distributed ledger, and the cryptography hash and all. So it's now time to understand how actually blockchain works. So for example, when we can look at on the image itself, then if Alice want to send something to some coins, some BTC to BOB, say for example, Alice wants to send one BTC to BOB. Alice sends it to BOB, Bob's BTC address from her wallet. So all she needed was as we discussed here, that here the address, Bitcoin address. So all that is needed by Alice is to scan that particular address of Bob, the BTC address, and send the required amount to him. Now, what is exactly a transaction fees is also involved in that particular transaction, because there are certain factors that we could discuss later, because that's a very lengthy topic itself, that how there's a lot of friction actually going on. So that is why a transaction fees is also involved in that. And the transaction, when Alice actually make that particular transaction, the transaction is actually presented to the network for the verification of whether her wallet has that amount or not. So as we discussed in the previous example of the bank, where you were trying to send some funds from your account to your friend's account, what exactly was happening? Someone in the middle, in the employee from the bank, was actually checking into your in the bank's ledger and checking into your account whether your account has that sort of that amount of money or not, and that then he was clearing that transaction or clearing the check. So similarly here, what's happening when the transaction is being presented to the network for the verification whether whether her wallet has that much amount of bitcoins or not. So a competition occurs between the nodes. So they, because it is a decentralized and distributed network, all the nodes who are willing to verify that transaction, a competition occurs between them. This competition is for the computation, and these nodes who are willing to verify the transaction are called miners in the Bitcoin blockchain term. And they compute, the more the computation power they have, the more are the chances that they will verify the transaction first. So this is called proof of work. because they have to put in a lot of computation power. So the better machine they have, the higher hash rate they have, the more are the chances that they will verify the transaction first. Because these are mathematical puzzles, these transactions are mathematical puzzles and they are very difficult to solve. But here again, a lot of network difficulty is there in the Bitcoin network. So now this is called proof of work. And this is a consensus algorithm used by the Bitcoin in this case. So this is how the things are. Like Alice was trying to send something, some BTC to BOB, and a transaction was present to the network, and the network. There are a lot of nodes that are willing to verify the transaction to earn some rewards. And after a few transactions are verified, block is created and written to the existing chain by the miner. So after few, the way Alice sent, and similarly other people will be sending, and after few transactions are verified, a new block is being created and written to the existing chain by the miner itself. The miner is then rewarded for verifying those transactions and writing a new block to the chain. So what actually happened is that the miner actually verified the transaction, and after a few transactions were verified, he created a block, he generated a block, and that he wrote that block to the existing chain of the blockchain. And for this purpose, the network will reward him with the transaction fees plus the reward for the generation of the new block. And this is how the new coins actually enter the market. So that is why anyone, so this is how the purpose of cryptocurrency comes into what we were actually discussing earlier, that cryptocurrency, one of the main purpose of cryptocurrencies was to keep the network running. So this is how they want to keep the network running. So because uh, uh, incentive is must to keep the, because if they do not get any rewards, why would they put up in, so much of money in their hardwares? Because for miners a lot of hardwares are required, high level, they need good level of machines. ASIC miners, they need ASIC miners, they are pretty expensive, they need a lot of electricity to run these machines, and they had to undergo a lot of competition from other miners. And we know that the network difficulty is the number of miners present. So network difficulty is increasing day by day in the Bitcoin network, and the more the miners will be in a network will be, the more the more competition will occur, and the more the competition will occur, it will be difficult for every transaction, so more the time it will take. So this everything is directly proportional. The more number of as the number of miners are increasing day by day in the Bitcoin network, the network difficulty is getting higher, and the transaction time is become and going higher. It is increasing the transaction time because a lot of competition is increasing day by day because of the increasing number of Bitcoin miners. So there is a lot of friction involved in all this, so the transaction cost is going up day by day in Bitcoin. It's also. So in the case of Bitcoin, a total of 21 million coins can exist, and after a span of 4 years, the reward amount is reduced to its half. And this year, in 2020, it became half, because it was a halving year for Bitcoin. And the year where this event takes place is called known as Bitcoin halving. So 2020 was a Bitcoin halving year, where of course the rewards went to its half. So all these rules were hard coded and put on the blockchain when the Bitcoin was created. So at the time of the when the Bitcoin white paper was written, so this was predefined that at max 21 million coins will exist and only that much coin can enter the market. And it was hard coded that the rewards will be reduced to its half after a span of 4 years, and the amount of reward that will be presented to the miners for generating a new block. So everything was hard coded, and that was put on the blockchain, and that cannot be changed because because we've already discussed that how secure a Bitcoin sorry a blockchain network is. Now talking about, I guess you must have got a good understanding of how the blockchain works. So now we've talked about a consensus a lot of time. We've included this word a lot of time. So what exactly a consensus algorithm is? So uh, different blocks in there. Sorry, there are different blockchain present in the market, and each blockchain uses different kind of consensus algorithm. And Bitcoin uses proof of work, and there are other that you're using. Ethereum 1.0 was using proof of work, but Ethereum 2.0 is using proof of stake. And what is the difference? We'll discuss both of these, and they are lot many, as you can see in the picture itself, and there are so many consensus algorithm. And what exactly proof of work is, we've discussed in the previous example of Bitcoin, where all the miners where all actually competing among themselves for the verification of where they were trying to verify the transaction. So the first the node that verify the transaction first was to get rewards from the network, and they had to put a lot of computation power for that, and this is known as proof of work. In case of proof of stake, let's take an example of a cryptocurrency that uses proof of stake is Cardano. So ADA is the cryptocurrency of Cardano. So what exactly happens in ADA or in proof of any cryptocurrency that is using proof of stake is that the validator has to put in this case, the validators are known as forgers. In the case of proof of work, the validators are known as miners, but in case of proof of stake, the validators are known as forgers. So in case of proof of stake, what exactly is done is that when if a node is interested to be a forger, he has to stake a certain amount of that cryptocurrency in the wallet. Say for example, the fees that is decided by the network is like for 10,000 coins of that particular cryptocurrency. Well, we were talking about the Cardano network, and that is the cryptocurrency of the Cardano is ADA. So if a node in the Cardano network wants to be a validator, he has to stake, for example, like 10,000 ADA in their wallet. Now, this is kind of a security that is kept by the network. If the node verify any invalid transaction, or it is it is by any bad person. So what exactly is happening here? Out of these staked coins, he will be the network will put a penalty on him, and a few of his coins will be charged from that particular stake. So that is kind of a punishment a network can give to a validator if he is trying to verify any invalid transaction. So this is the concept of proof of stake. In the proof of work, what exactly was happening? A lot of computation power was involved, and to run that computation power, a lot of energy was required, and that energy was actually purchased with your real money. So a lot of physical energy was actually required. A physical cost was actually involved, In proof of stake, no physical cost is involved. So they created this system that the validator has to stake a lot of coins, and if we verify any invalid transaction, they will he will pay a penalty from those particular stakes. We have other like practical Byzantine fault tolerance. So Byzantine fault tolerance is a very famous and very common consensus algorithm that uses the concept of Byzantine general uh, like consensus, and it is here. Now they've been using practical Byzantine fault tolerance where, for example, like I can give you an example like of a voting system. They includes a voting system. For example, if we have 10 nodes and there is a voting going on for any particular decision to come up for a consensus, and say for example, four of the nodes are not responding. So those four nodes are considered that the network is considered to be like of stakes, and a mutual understanding is done between the nodes and a decision is being taken. So proof of elapsed time is another, and there are so many. Proof of elapsed time is mostly used in permission blockchain and the enterprise level of blockchain. So we'll discuss that in future in the future slides. Now we are here with the types of blockchain. So generally, when we categorize blockchains, we categorize into three types of blockchain generally, and that is permissionless blockchain, also termed as public blockchain, and we have permission blockchain, also termed as private blockchain, and consortium blockchain, also termed as semi-private blockchain. So what are the differences we will discuss and we are almost at the last of our session. And in the permission blockchain, what exactly is happening that anyone can join the network. Say for example, the Bitcoin blockchain is the perfect example of permissionless blockchain. Anyone can join the Bitcoin network without revealing his identity. And here, all the nodes have equal rights. The identity of the node is anonymous. As I already mentioned, that anyone can join the network at any particular time, and anyone can leave the network at any time without any prior permission. And your identity is always anonymous. You can do anything in the network or whatever is required. So this is what a permissionless blockchain is. So most of the time when a project is quite public, it has to be permissionless. And now coming to the permission blockchain. So different nodes have different rights here. So in the case of Bitcoin blockchain, what was the scenario was that the blockchain had different all the nodes had equal rights, but in this case the blockchain has in this case the nodes had different rights, and these different rights are given by the kind of the authority of that particular blockchain. So here one node may not it depends on the architecture of the network itself, whether the nodes know each other or not, and this depends entirely on the network. And this kind of networks are used in enterprise solutions to solve this. Coming to the third part, we'll discuss more of these in detail. Now coming to the consortium blockchain, also termed as semi-private. Here, it has a controlled user group. Each node knows the other node, and so the identity is not anonymous at all, and work across different organizations. So in the permission blockchain, what was actually happening, it was for like enterprise solution. And in the case of consortium blockchain, it is cross company. If two or more companies are trying to collaborate for something, they want to use blockchain, so they will be, it's better if they use a consortium blockchain. So let's take an example. We've taken an example of permission and blockchain, that was Bitcoin blockchain. That was the perfect example for that. But in the permissioned blockchain, what is actually happening say for example, we take the example of Tata. Tata is a big company, have different units. We have and they have TCS, they have Tata Automobiles, they have Tata Steels. So if Tata decides to if Tata decides to put all its data on blockchain, and they want to create a blockchain for all the units or the different units, so they will go for a permission blockchain, because there is no point of putting their complete data on a permission blockchain where anyone can join it, because that doesn't want any data that belongs to the company to go outside the company. But in this case, what exactly why Tata is trying to use such kind of such kind of thing is that maybe I'm just giving an example. Maybe it could be possible that Tata Steel doesn't want to trust TCS for any sort of transaction that's taking place between them, and they want to put it on blockchain. So later on, the TCS could not deny that that transaction couldn't take place, that transaction didn't take place. So this is some sort of that kind of example where a different sectors within a company can be put on blockchain, and they can share information for among themselves, and each and every information transaction that's being taking place between these units, from Tata Automobiles to Tata Consultancy to the Tata Tea or whatever, different. So they could be stored on permissioned blockchain, where all the nodes actually are known to each other. And this is one of the example of permission blockchain. So why in the case of permission blockchain, cryptocurrency is not much needed. So is most of the time it's not needed, because you don't have to back that particular you don't have to back that blockchain with the help of various people. So coming to the last point, because we already running late with our session, and now we're coming to the consortium blockchain. Now, for taking example of consortium blockchain, let's take an example of the KYC of in the various banks. For example, the KYC, for example, the banks. Different banks, the national banks, all the national banks, and all the private banks, and all the insurance company come under one consortium. They form a consortium, and they have a common ledger between them that is running on blockchain, of course. And say, for example, you go to HDFC Bank and you ask them to open your account, savings account. They ask for a KYC document, and they'll process all your documents. A lot of cost is involved in that particular documentation, and they need to verify all your details. And now, and the next day you go to Axis Bank and you ask them, so they'll go undergo the same process again. So what exactly is happening? You're being affected by in the terms of cost, and the banks are being affected in the terms of the money, in the terms of time, and you are also affected in the terms of time, because you have to visit both the branches again and again, and for the same purpose. And this is how. So if let us take an example that if all these banks can collaborate with each other, forming a consortium using a blockchain, and when you went to HDFC Bank, you had your KYC done with the HDFC Bank, and when you go to Axis Bank, you inform them that I have opened an account with HDFC recently, and what Axis Bank can do is they can ask for your details from the HDFC Bank. So that particular transaction where Axis Bank is asking HDFC Bank could be stored on the blockchain, because HDFC Bank does not trust Axis Bank for such kind of information. Then HDFC Bank will ask your permission whether to share your documents with Axis Bank or not. You will allow them that particular transaction, and that is also stored on that particular blockchain. And this is how all the things are taking place. And HDFC Bank share their documents with Axis Bank, and so this is saving a lot of time, and this is saving a lot of cost that is involved in KYC thing. So this could be done. This could be done over blockchain. So blockchain had made these things very easier. Now, this was generally the categorization in journal of blockchain, and but the actual architectural categorization of blockchain is somewhat here. So I'll not go into the detail of this because we already reading quite late, and you can see it, and I can provide the PPT. So if you want to get into the detail of what exactly it is, so it is very simple. You can just take a snapshot of this and a screenshot of this, and you can refer it later. So it's very simple. So the categorization is being done is like in the permissionless we have both public and private, and in the permission also we have both public and private. So things goes like permissionless public, permissionless private, permissioned public, and permission private. So this is how the actual categorization is based on the architecture of blockchain, and they have different rights which are mentioned over here. Now talking about the smart contracts. So after Ethereum was developed in 2015, a new concept of smart contracts was introduced. And what exactly are they? They are simply lines of code that are stored on blockchain, and they automatically execute when a predetermined terms and conditions are met. So event is occurred when, say for example, you decide it is, you can consider it a simple agreement, and in every agreement you have terms and conditions. If those terms and conditions are met, an event is actually occurred. And same is the case. This is the e-version of that particular agreement that is running on the top of blockchain. So the best part of this e-agreement, you can call it e-agreement because that's the electronic version of your physical agreement, and where all the terms and conditions are written, are actually coded in the terms of a programming language, and they can actually create event whenever any of the terms and conditions are met. So the best part of this once written on the blockchain, they cannot be edited. And if you want to add any terms and condition to that particular smart contract, an entirely new smart contract is to be made. You cannot edit it. So that's the best part of it. And a lot of automation can take place. For example, if you want to buy a car and you go to a showroom, so there is a lot of long process that has to take place. You talk to the owner, you talk to the salesperson, then they ask you whether you need a financing or not. Then you talk to the financing team, and they verify your document. They check the financing team actually talk to the credit rating company. So if all these things are put on blockchain, and this could be done easily, all these steps that you are undergoing manually could be done easily with the help of the blockchain. You can just simply ask the showroom for the car, and the smart contracts can click whenever any particular event is occurred, smart contract can do all the stuff itself. So now industry is to be disrupted by quite late. Industry is to be disrupted by the blockchain. Now we talk about the banking industry is the first one, as we've already seen what Bitcoin has done with the cross-border payment, and the decentralized finance. So earlier, what was exactly happening with the help of a SWIFT payment system? What exactly was the thing is, when we tried to send some money from US to here, there was a lot of friction involved. Like I was sending money from my bank was sending to the RBI was sending to international bank, and international bank was sending to the bank in there. So there was a lot of ledger that was need to be updated. But and when there are a lot of ledgers that need to be updated, there was a lot of friction that was created, and that was that a lot of cost was involved in that. So whenever I was sending, say for example, $100 to my friend, or 100, my friend was sending me $100, I was getting $94. 6% of the fees was going in the as transaction. So when we are going for a larger amount, so this fees can cost us a lot. But Bitcoin changed it a lot. I can directly send funds cross border to like any of the friends sitting in any corner of the world, and I can just simply send him, I push him some bitcoins to his wallet from my wallet, and there will be a very minimum fees involved in that, and it could be settled in just a fraction of like 10 to 15 minutes. And whereas in the case of Swift, that the settlement was being done in like 2 to 3 days. Now talking about the DeFi thing, so decentralized. So earlier, what exactly was happening? We were going to the banks. We were keeping our money in our saving accounts. Banks were giving us interest for in return for that amount that we were keeping in the savings, and banks were actually giving that amount to the in the form of loans to the corporates and to the individuals whoever was seeking for a loan. I mean, so they were earning amounts, and they were earning a lot of money in form of interest, and they were paying a fraction of that to us in terms of saving account. So if you know that how much the bank charges you for how much interest bank charges for your loan, and how much interest does the bank pay for your savings account, there is quite a difference between them. So now there are a lot of DeFi company, decentralized finance company, where blockchain is being used as the trust factor, and both the lender and borrowers and the lenders are working on the same platform. A person, you can be a lender, you can put your funds over on that particular network, and you can lend your funds to anyone. You can earn a good interest out of that, and the person who is seeking some loan, or he can borrow it from you, and the network fees is very less as compared to that of the bank. So the banking industry is going to be disrupted for sure. It's almost half. 50% is almost disrupted, and the remaining 50% will be disrupted very soon. Now coming to the real estate industry, land ownership, we've already discussed the example of how actually distributed ledger technology can help in the land ownership thing. Earlier, we've seen a lot of fraud cases where in terms of land ownership kind of a thing, but here this could be improved at another and could be taken to another level. Now, coming to the agriculture industry, again, distributed ownership was not possible manually, but blockchain and smart contracts can do that easily. A lot of different small farmers can contribute to make one bigger land that could be a distributed energy. A lot more than one person right now. Only one person can own a particular vehicle or tractor, but in case of blockchain, can make it possible for the distribution. Only one tractor can be owned by 5 to 10 farmers, so that will help the agricultural industry again. Logistics, you can track yourself with the help of IoT devices and blockchain. IoT devices can put all the data, keep updating all the data to the blockchain, and you can track your goods, whether with what temperature they were stored and where they were at what time stamp, and everything related to the healthcare industry. Again, medical data sharing can be very useful in terms of blockchain, where the research company can do a lot with the actual data that they can get from it. And the legal industry, again, verification of the documents, as we discussed, because smart contracts can do a lot. So we're already running quite late, so thank you. And the last thing that I want to say, that blockchain is not a use case of internet, but it is a parallel and as fundamental as internet itself. So we'll see a lot of things coming on the blockchain. And sorry, we ran out of the time and couldn't complete in a decent way the last portion. The industry is to be disrupted. I had a lot to say in that part also, but I think you must have enjoyed this workshop. It was pretty lengthy, but anyhow, thank you. Any questions? If you have any questions, so you can ask me about it.
Any question from participant side? Hello, any question from participant side? Yes, there is a hello, sir. There is a no question from participant side. It means your whatever your topic, all concept is cleared. That's why now we will do vote of thanks by Professor Aruna Kamble, ma'am.
Ma'am, I have one question.
Okay, okay. Yes, ma'am. Yes, ma'am. Yes, ma'am.
Sir, in a blockchain, there is a timestamp. Okay. So if there is any conflict in the timestamp technique.
Hello.
Yes, sir. Yes, sir, ma'am. I asking the question.
Sir, you are audible. Sir. Hello.
Hello, sir. Sir, can you get back to our question?
Hello, sir. Hello.
Hello, sir. Is it audible?
Okay, ma'am. I will ask later. Thank you.
Sir, is it audible?
Hello.
Yeah, sir.
Yes, sir.
Sir, there is one question.
Sir. Hello. Sir. Hello. Sir, are you audible? Hello. Hello.
Here.
Sir, ma'am
Yes,
is
sir.
having one question.
Yes, sir.
Hello, sir. There is one question by Anjali, ma'am.
Hello, sir.
ऑडिओ होत नाही म्हणे त्यांना मॅडम.
हा मला परत विचारेल चालेल. Thank you, ma'am.
Okay, ma'am. So, I will just conclude. So, sir has given the presentation. So, it was quite simple and clear. And sir has covered the topic, that is centralized and decentralized network, digital ledger. Then he has also covered blockchain transactions, cryptocurrencies, cryptocurrency wallet, and many more concepts he has cleared, along with a lot of examples, interesting examples. So I will just conclude the session, and I will thank to all the participants as well as the speaker of today's session. So with this, I conclude the session. Thank you. Thank you all.
Thank you, sir. Thank you, sir. Hello, you are audible, sir.
Hello. I'm not audible.